Hi YouTube, Tim here. In this video we're going to look at word problems that deal with exponential functions where we have something doubling or tripling in a certain amount of time, and we're going to figure out how long that takes. For instance, the first question reads, the function f of x equals 12,000 times 2 raised to the t over 215 power. That gives the number of bacteria in a petri dish t minutes after the initial observation. How long does it take the amount of the bacteria to double? So it doubles when the power, or when 2 here is raised to another 1. So 2 to the first power, it's going to double, then it's going to double again at 2 to the second power, then 2 to the third power, and so on. So we can see when it initially doubles when t over 215 equals 1. So what we can do here is we can multiply both sides by 215. That's going to undo the division of 215 on the left-hand side. And we're going to do what we do to the left-hand side to the right-hand side of the equation to keep the equation, or both sides of the equation, equivalent. And 215 divided by 215 is just 1, so we have 1t here. That equals 1 times 215, so that equals 1 times anything is itself, so it equals 215, and that's minutes. Okay, so that's the first one. Let's go take a look at the second one here. And as we go through these, you might want to try and pause the video, try the problem yourself, and then see if it matches what I'm doing. So the second one, the function f of x equals 9,994 times 3. The t over 14 power gives the number of bacteria in a petri dish t minutes after the initial observation. How long does it take the amount of bacteria to triple? It's going to triple every time 3 is raised to, well, it triples once at 3 to the first power, then it triples again at 3 to the second power, and so on. So the first time it triples is when this t over 14 equals 1. Okay, so we're going to set t here over 14 equal to 1. And we want to solve for t, so we're going to multiply both sides by 14. Uh, 14 divided by 14 is 1, so we can cancel those out and just write t equals 1 times 14, which is 14. Again, the unit here is minutes, so 14 minutes till it triples. And that's the solution for that one. Let's take a look at another one. So problem 3, the function f of x equals 115,021 times 2 to the t over 111th power gives the number of bacteria in a petri dish t minutes after the initial observation. How long does it take the amount of bacteria to double? Okay, so it's going to double when, again, just like the other ones, when t over 111 equals 1. That's the first time it doubles. So we're going to set t over 111 equal to 1. I want to get rid of the division by 111, so I'm going to multiply both sides by 111. 111 divided by 111 is 1. 1 times t is just t, so we have t equals 1 times 111, which is 111. And that's minutes. And there we go for that one. Let's try one more. All right, problem 4 reads, the function f of t equals 1,225 times 3 to the t over 67 power, which gives the number of bacteria in a petri dish t minutes after the initial observation. How long does it take the amount of bacteria to triple? So that's when 3 gets raised to the first power, so t over 67 equals 1. It's a t over 67 equal to 1. And we want to get rid of the division by 67 on t, so we're going to multiply the left-hand side by 67. And we have to do that to the right-hand side. 67 divided by 67 is 1, and 1 times t is just t. And that's going to equal 1 times 67, which is 67. The units here are minutes, but it could be seconds, it could be hours, and so forth. Just pay attention to whatever the units are. So we're going to say 67 minutes. Now you may have noticed in these problems that typically it's going to double or triple when the numerator is equal to the denominator. So hopefully you notice that pattern and it's helping you out with these problems. If this video helped you out, please like and subscribe.